Good morning, guys. Good morning, everyone. Welcome to my channel. This is Dr. Teju. Today's lecture is representation of syntactic structure. So, in the last lecture, we completed about that how to construct the syntax trees with complementizer, without complementizer. Okay. So now we are going to discuss about that representation of syntactic structures. So here the representation of syntactic structures are used two approaches. So first one is phrase structure graph and the second one is dependency graph. So coming to the first one, phrase structure graph, how we will represent the syntactic structure by using these two approaches means using the tree bank we can represent. So in the tree bank we know that already the last lecture we discussed, right? So in the tree bank all the corpus of text we can represent in the form of tree bank, right? In the we can represent in the form of tree structure. So from there, by using this tree bank we can represent the syntactic structure of the given sentence. Okay, so now coming to a simple example. Here we are taking the sentence, the grammar. See this one sentence I'll wrote here also. I hope everyone will understand by writing like this. Okay, sentence followed noun phrase and verb phrase, and here the noun phrase are in the given sentence John and pockets, and determinant and or you can say noun and noun phrase and preposition phrase. Then coming to the verb phrase are having followed with the verb, noun phrase and verb phrase and preposition phrase. So that means you can use either these both or either these both, like that. Then coming to, we need to write a grammar for verb and also preposition phrase, right? So verb, coming to the verb, the given sentence we need to use the verbs are bought, and the determinants we are having like a, and the noun we are having a shirt, right? Then preposition phrase only left over. So from the sentence of noun phrase and verb phrase, noun phrase grammar was completed, then verb phrase grammar was completed. So from the noun phrase we need to write down a grammar for determinant, noun and preposition phrase. Okay, and from the verb phrase we need to write down the grammar for verb phrase and preposition phrase. So now verb is having bought and determinant is a and noun is having a shirt, right? And only the thing left over here in the grammar is preposition phrase. So the preposition phrase is nothing but preposition and NP. Again we need to write a grammar for preposition, that is with. So now all the phrases are completed in the given grammar. So now let me construct a parse tree using this grammar. So this grammar can produce the syntax analysis like John bought a shirt with pockets. John bought a shirt with pocket. So this is the sentence. So by using this sentence, by using the grammar above constructed, we will construct the parse tree. So the sentence we are giving noun phrase, following noun phrase and verb phrase. And the noun phrase, see, based on our sentence, the noun phrase is having like so check this one. Here in the noun phrase we need to write like directly John and pockets. Also we need to write determinant, also we need to write noun, and also we need to write noun phrase and preposition phrase. Okay, so from these grammar we need to take one of the thing. based on our given input sentence. So what we took here, the noun phrase, directly in the first word is in the given sentence is John. So we will take the noun. So noun, then noun is John, right? So then noun is John. Now the noun phrase was completed from our given sentence. Now coming to the verb phrase. So verb phrase, we need to take like a verb and noun phrase, these two things. The verb is bought. And in the noun phrase, again we need to take based on our given input sentence, that is determinant and preposition. So determinant we are having in the given input sentence is a. And preposition phrase, noun phrase, preposition phrase, and also the noun phrase. So noun phrase, noun is shirt, preposition phrase, preposition is with, and noun is finally we are having in the given sentence is pockets. So now we constructed the syntax tree for John bought a shirt with pockets by using the constructed grammar. Right? Hope everyone will understand how to construct the parse tree, syntax tree with the help of given input sentence and constructed grammar. That is a production of rules. So that is the general procedure. Now coming to the first approach of representing the syntactic structure is phrase structure graph. Phrase structure graph. Okay. So this phrase structure graph, we also called it as a constituency graph. Okay. So the phrase structure graph also called as a constituency graph. Who was invented this phrase structure graph? Noam Chomsky. So he is the scientist, one of the scientists. He introduced this phrase structure. He invented this phrase structure graph. So in this phrase structure graph, each node in the constituent, each node, suppose consider this is the tree, like this. Suppose consider this is the tree. So in the tree, each node, these are the nodes, right? These are the nodes, right? So each node in the constituent tree represent a phrase. So the name itself you will understand. Phrase structured graph, right? Phrase structure graph means the nodes we are representing using the phrases. Phrase is nothing but what? Phrase is nothing but what? Maybe a noun phrase, or maybe a verb phrase, or maybe a preposition phrase, like that. Okay. And the relationship, this one, see the edges, this edges between the each nodes, it shows the relationship between these phrases. This already we know. So we know that already how to construct the syntax tree and how to represent the nodes of syntax or parse tree, and the edges can be used to connect the nodes. All these information already we know. But in the phrase structure graph, nodes can be represented using the phrases. Between the phrases, we need to represent the relationship, right? For that, we will use the edges, right? So the phrases we can include here in the graph, in the structure of a tree is, see this one I wrote already, noun phrase, verb phrase, preposition phrase, and etc. and so on. So we can use a kind of phrases. And here I wrote very simply, nodes can be used as a phrases, edge can be used to represent the relationship, right? Okay, so let me explain with a simple example how we will construct the phrase structure graph, how we will approach the phrase structure graph representation, graph in the sense tree representation. Okay, take an example, simple example. The cat chased the mouse. So this is our input sentence. Very simple example we took. The cat chased the mouse. So from this given sentence, we need to write, or we need to divide the phrases. So from this sentence, this phrase is nothing but what? Remember, combination of two or more words, that we need to remember. Phrase is nothing but combination of two or more words. Two or more words. Okay, so here chased, this is the relation, it's a nothing but a verb, the mouse. So here from this given sentences we divided three phrases. This is the first step. Then how to construct the phrase structure graph means we need to check the grammar, constructed grammar. So here see this one, sentence followed noun phrase verb phrase, noun phrase determinant and noun, and verb phrase followed verb and noun phrase. So this grammar we need to see. By using this grammar we will construct the parse tree, that is phrase structure graph, phrase structure approach. So these CFG is very important. We need to aware about these rules, right? So then after understanding the rules, that is CFG, we need to tag a sentence with the phrases. After that we need to connect a hierarchical representation using the edges. So same top down or bottom up parsing we can do. So here the first thing, the given input sentence, we need to understand that the parts of speech tagging. The means determinant, cat is a noun, chased is a verb, and the is a determinant and a noun. Okay, so this already we know. So now we'll start a top down representation of phrase structure graph. So top down representation of phrase structure graph means, see here, we need to write the directions that we need to remember. Okay, the sentence in the given grammar, remember the grammar, noun phrase, verb phrase, and noun phrase they given like a determinant and noun, and verb phrase they given verb phrase, verb and noun phrase. Okay, then in the noun phrase determinant and noun. So now we understand that in the given input sentence parts of speech tagging, the cat chased the mouse. Okay, so this is the way of constructing the phrase structure graph. If you give the directions from top to bottom, or if you give the directions from bottom to top, that is the representation of a phrase structure graph. Okay, so yeah, so this is about the phrase structure graph. Then here I given some points, very important points. If you want, you can make it as a pass and you can note it down, all these points regarding this phrase structure representation. Okay, these things, very important point. Whatever I explained now, that points only I wrote here. Okay, right? This is phrase structure graph. Till here it is a phrase structure graph. So now coming to that dependency graph. So dependency graph, remember phrase structured graph can be represented either top down or bottom up. Based on our representation we need to provide the directions, or without directions also it will be applicable. Okay, but in the dependency graph compulsory we need to show the directions. So that's why we can call it as a directed representation graph. Dependency means what? One node can be dependent on the other node, like that. So we can call it as a direct edges. Using the directions we can represent the graph. So who introduced this dependency graph? Lucian Tesnier. So he is one of the scientists. He introduced this dependency graph. So here in the dependency graph, remember one more important point, difference between the phrase structure graph and dependency graph is, in the phrase structure nodes are represented with the phrases, but in the dependency nodes are represented with the words. That is the main difference. And one more difference is relationship can be represented using the direct edges. Relationship can be represented in the directed edges. Okay, then coming to here, each edge in the dependency graph indicates dependency relationship between the head node and child node. Head node and child node. For example, this is a head node and this is the child node, and this dependency relationship shows head node and child node relationship. So head node is also called as a governor node and child node is also called as a dependent node. So dependency graph actually typically rated at a single node representing the main verb of the sentence. So one more very important difference between the phrase structured graph and dependency graph is, in the dependency graph, first thing we need to find out verb. We need to find out the main verb in the given input sentence. This main verb is a root node of our graph, root node of our tree. So the main verb in the sentence is a root node of the dependency graph. This we need to remember. Okay, so let me take a simple example. The same example we will take, the above example. The cat chased the mouse. Okay, so from this we need to divide the sentence into words, and from this sentence, this is the main verb. Chased is the main verb. Okay, so you need to tag the parts of speech. After tagging, it is very easy to find out the main verb. Okay, after finding the main verb, started constructing the dependency graph. Okay, so here, yeah, so this one, first thing is chased is a verb, it is a root node, so we can make a relationship with other nodes using this verb only. So first, chased, who chased? The cat chased. So how the relation, you understand here, how the relation? Who chased? Cat chased. What chased? Mouse. The mouse. The mouse. The cat chased the mouse. Okay, so now the relationship between each nodes are understood. By using these understanding structure, you can construct the parse tree, dependency parse tree, dependency graph. So chased, who chased? Cat. The cat. What chased? Mouse. The mouse. So the cat, see here, the cat chased the mouse. The cat chased the mouse. So in the sentence, chased is the verb. That's why we are constructing chased is the main node, root node. Okay, so this is about the how to construct the dependency graph. And here are the some differences between the phrase structured graph and dependency graph. Okay, so see here, so same thing, whatever things we explained in that Noam Chomsky. Okay, so then same thing, whatever you understand from the phrase structured graph and dependency graph, keep that words in the mind, and based on that things you have to make a differences. It's very simple, right? So see here, introduced by who, scientist name, first thing. Then nodes are phrases here, and here are the words, and sentence is the root node in the phrase structure, and verb is the root node in the dependency. Then phrase structure graph is undirected and this is directed, and undirected edges we can use relation with the nodes, and here direct edges we can use through relation with the other node. So same example, right? This is about your dependency graph. Hope everyone understand about constructing the phrase structure graph and dependency graph, the representation of a phrase structure graph and dependency graphs. Thank you so much. Hope everyone will understand. Please, if you like my video, hit the like button. Thank you so much. Support my channel. In the next video, I'm going to discuss about that parsing algorithms. Thank you guys.